So in unit 2, we saw a certain category of problems which can be solved by a concept called divide and conquer, right? Similarly, in unit 3, we will see a category of problems which can be solved by a method called greedy method. Now, to understand what is greedy method, I've just taken one example here. This is, assume you have, say, a supermarket near your house and there's a sale. And say there's some special offer, you get chosen as one, say you won a special offer where they'll tell you that you can take a trolley, go into the supermarket, say you will be given 5 minutes time. You can put anything you want in that trolley. Okay, so that's the price that you have won. That they let you free in the supermarket. You pick anything that you want, put it up in the trolley and come back. Okay, now the constraint is, so this is the problem statement. Okay, so the problem statement is you have to fill the trolley with items so that you get maximum profit out of the sale. So obviously your intention is, I will go pick up the items where I get maximum profit. Okay, however, they put one constraint. Okay. Okay, let's see if we'll come to the constraint part a little later. If this is the problem statement, okay, you all understood what the problem statement is? So imagine it's a hypothetical, okay, it will not happen to you, but just for fun purpose, let's imagine that you get a chance to take an empty trolley, go to a supermarket, and you pick any item that you want. Okay, what will you do? What will you do if you are put in the situation? Rafia?
Yes, ma'am. Ma'am, can you repeat, ma'am?
Okay. Say, suppose you have won a prize, okay, and you are led to go in a supermarket with an empty trolley, and your choice, you can pick anything and fill up the trolley. What you will do?
Will fill up, ma'am.
Okay, your intention is to maximize the profit. So how you will fill up? Like, will you take only all candies and put it? You will take some small chocolates and fill your trolley. What kind of items you will fill your trolley with? Costly, yes. So you want to make maximum use of that, right? So you'll go look out for the costly items and you'll put it, right? Say suppose you, when your trolley may look something like this, right? Really? If suppose you have no limit, okay? I mean, we are greedy by nature, right? We try to take as many things as possible. So if they don't put any constraint, probably your trolley will look something like this, right? Anything that you see around, will just put it up and take it out, given a chance if you win such kind of a competition. Okay. Okay. Now let's imagine if there's one constraint. Okay, they say, okay, you can go pick up anything in that supermarket, fill up the trolley, but make sure the weight of the trolley should be less than or equal to 10 kg. That means I cannot just dump like this, right? I can pick anything, my choice. Okay, but the weight of the trolley, now it is constrained. I cannot put max weight. I can fill only up to max 10 kg. Okay, now with this constraint, who is there? Muskan, you want to answer? How will you fill your trolley now? So you have a constraint now. Muskan?
Yes, ma'am. What, ma'am?
See, now you have one constraint. Okay, you can fill any item in your trolley, but the weight should be less than 10 kg. So what items you will start filling in your trolley? How you will fill the market? If you go to the shop, how will you fill the trolley?
Only the required items, ma'am.
Only the required items. Okay. How will you ensure weight is less than 10 kg? Say your required items, maybe say I want 10 kg wheat and say I want 10 kg rice. This may be your required. You may just need 2 bags, okay? But if you take only the required items, is it okay? Is your constraint satisfied? Oscar?
No, ma'am.
No, right? So what you will do?
We'll take the less weight, ma'am.
You will take the less weight. Say, suppose you went for this. Okay. You will just fill this and you will come out. Okay, let me put it this way. Say, suppose you have 5 kgs. Okay. Say, suppose you have a 5 kg wheat bag. You will fill this and you will come out. Because now next bag, if I take it will be 10 kg. So it will go overweight. So you will just fill your trolley with this 5 kg wheat and will you come out?
No, ma'am.
What you will do? What else you will do?
Ma'am, will take 1 kg, ma'am.
Yeah,
Of different items.
Different items. Okay. So say suppose this was 5 kg, you put 1 kg, it is 6 kg. So you'll come out now. You leave
Yes,
the
ma'am.
chance, huh? You leave the chance and come out. Imagine it's free. Why will you settle for less? Your bag has 6 kgs totally. But what is the limit? How much you can take?
10 kg.
10 kg. So will you leave your trolley empty and you'll come out of that competition?
No, ma'am.
No, right?
No, ma'am.
What you will do next?
We'll look for 4 kg thing, ma'am.
Yeah, you look for anything where you can maximum fill that trolley and then only you will come out. You will not want to keep your trolley half empty and come out, right? Come on, everything is free. Why do you want to waste it, right? Okay. So you all understood what it means by having maximum profit. Okay, with this example, what did you understand when I say maximum profit? Here, what is the profit that we want to take? What is our profit? When I say maximum profit in this shopping cart example, what is the maximum profit I'm getting? Okay, profit is measured what in what way it is measured? Suppose you get these items, right? Say suppose 2 people went into this competition. Okay, you went and your friend also went. You filled up your trolley. Okay, the other friend also filled up the trolley. And both, because the competition itself was telling that it is 10 kg, right? You both filled up with 10 kg. Now, how do you come out and say that I was more profitable than you? How will you compare and say I am more profitable than you? Because weight is still the same, right? Both the trolleys. How do you measure profit in this case? Nimra?
Price matters, ma'am.
Price matters, yes. So now what you will do? Okay, yeah, both our trolleys are full. Okay, let me check what is the cost of my trolley. How much did I make? How much free items did I earn? Say if you start counting each of the prices, you say you may have earned some 5,000 rupees free. Okay, here they picked up the items, but they were all very cheap items you picked up. You filled up the trolley, but they were all very cheap items. Say you just picked up items worth 2,000 rupees, right? Who is more profitable here? The first person or the second person? Who is more profitable in this case?
First person.
First person, right? So the problem statement was same for both the people. Like you go with an empty trolley inside, you fill whatever items you want. We did not put any limit on the cost. Okay, we only told you only weight should be 10 kg. Now this person was not just looked at the items, okay, how big, how small the boxes are or packets are. They also looked at the price. Okay, given the chance, let me pick the one which is more costly. Sometimes, no, more costly will be even your small box. Not necessarily that a big box is always costly, right? Your big box may be cheap, your small box also may be costly. So one person looked at, say, the cost and tried to fill the items which are of more cost, right? The other person, maybe they didn't have time or they forgot to check the price. All they thought was, okay, I need to make sure my trolley is filled. So I start filling up the boxes, and the moment my trolley became full, I stopped. I never bothered to check the box, right? This is second approach. But later when you come back and see, oh yeah, my items were lesser cost than this item. So to summarize, there are three ways you can solve this problem. Okay, now, right? So one is you have the weight, the other one is you have the cost of the items. So what are the three ways in which I can fill this? I can solve this problem. Problem statement is to fill the trolley with maximum profit. Okay. So one thing is, say, this was one example. Say they picked up items. Okay. Say they picked one item, which was 10 rupees, 10 rupees, 5 rupees, 100, okay, 50 rupees, 800 rupees, 700 rupees. So when you finally evaluate, your total cost was 1,780. This was the cost of that first person I said, no? Say maybe this is person one. Person one's trolley is so much. Okay. Cost is 1,780. Now the second person, what they did was they also filled it. Okay. But they made sure they pick up cost with items with higher cost. Okay. Say, okay. Say this is just another example. Say this is person two. Okay, they also randomly picked up something and they got it. Okay, now when you compare, obviously this is more costly. 1,780 is more costly than 1,180. So we say that this person has made the most profit. Okay. Now one more thing is there. Okay. Now suppose you fill your cart. Suppose you were filling the cart. Okay, you put all these boxes. This is all full. You were full. Okay, here also you were full. Now you're left with some box. You're left with some space in your trolley. Okay, so much space. Now if you put any box, right, it is much bigger. You can't fit it in, right? Not possible. But suppose given a chance, suppose you're going. Say this is say a bunch of bananas. Okay, can you split it? Can you split this instead of taking the full bunch? Can you make a smaller bunch and put it how much of a space is there? Can you do that? Break them. Can I take just 2 bananas and I put it?
Yes, ma'am.
You can break it, no? You can split it. So I'll just put whatever, how much ever is the capacity. So now I will introduce you to now 2 concepts. Okay. There is something called feasible solution and there is something called optimal solution. Feasible solution, which means it's a solution to a problem, okay, which satisfies all the constraint. It is meeting all the constraint and it is satisfying. So this is a feasible solution. But optimal solution is, it is also solving the problem. Okay, the problem is solved. It is also meeting all the constraints. All constraints are met. However, it is giving me maximum profit. Right? When I get the maximum profit, that solution is my optimal solution. Okay? That means I can have many feasible solutions to a problem. Okay? But whichever is giving me the maximum function, maximum profit, that only will become my optimal solution. Okay, so highlight this part. So what does greedy method or greedy algorithm? You can say greedy method or you can also say greedy algorithm. Okay, so what does this do? It builds the solution. Okay, it builds the solution step by step. Okay, one step at a time, it tries to build the solution. When I'm going to define this problem, right, you should start imagining in your trolley. You keep the trolley use case in your mind. So how did we solve the problem of filling the step by filling up this trolley? You put one item at a time, right? Item 1, item 2, item 3. So slowly, step by step you do, and finally you will fill the trolley. Okay. So solution, greedy method tries to build a solution step by step. Okay. Now at each step, what do? At each step, you have to choose the best solution. available at that time. Okay, you have to choose the best solution available at that time. Like for example, when you were picking the item 1, okay, you were having some, you had these 3 items in your mind. Item 1, item 2, item 3. Okay. So you realized, okay, the cost of this is 500, 200, 100. Okay. Suppose you had 3 items in front of you while filling up this trolley, right? So at this step, when you didn't have, when you were in step 1, okay, none of this was there. Okay. Greedy algorithm, what will do is at every step, that means I'm still building my step 1. At that time itself, I will be greedy. I will choose which one of these possible options is best for me, right? So if I apply greedy algorithm or greedy that method in the step 1, which one I will choose out of these 3? First, because now I'm not just looking at picking the items, I'm also checking the cost of it because I want to get maximum profit, right? So based on that, okay, I will pick this item 1. Okay, so you have to choose the best solution at every step. You have to choose the best solution available at that time. The best feasible solution, that is, which meets all the constraints. Finally, what you do at every step, what after, let me add, finally, that means after you have finished all the steps, what you will achieve? You will achieve the best feasible solution, which meets all the constraints. Once chosen at every step, whatever choice you do, the solution cannot be changed. Okay. One other point in greedy, why do you have to do this is, the logic of doing by the greedy algorithm is, it says that by finding locally best, like locally optimized solution, means what? In step 1, I choose whatever is the most costly item. At step 2, again, I choose whatever is the most costly item. So every step, you're finding a locally best solution. By doing so, I will be getting the globally best solution. Right? This is one more point when it comes to greedy algorithm. Okay, the greedy method says that by finding locally best solution, you will eventually come up with a globally best solution. If you have understood what we explained, you should be able to do this control abstraction. Control abstraction, we saw control abstraction means how do you define greedy method like an algorithm, right? So what it is doing, there is a container, okay, some array, they take some array only, okay, it has 1 to n elements, okay, this is taken as the input. Finally, you have to fill your solution. Initially, you initialize the solution to empty, okay. Now you check every item in this, okay, that means 1 to n, you're checking every item in this, you're selecting something from this, okay. Now, if you're selecting one item and you're checking, is it a feasible solution? Means what? Whatever I have chosen, is it satisfying all the constraints? Is it satisfying all the constraints? If it is satisfying, then you add the final solution, okay? Then the solution is union of these two. That means what? At step 1, my solution is empty.
Excuse me, ma'am, repeat from first.
Yes, I'll repeat. I'll explain the step by step, okay? Let's take, just visualize this. When you, anytime, no, again, one suggestion, anytime you come across this, you have to visualize. Take a paper and start drawing what they are telling. A, 1 to n. That means what? This is some, they're calling this as A. It has some elements, 1, 2, 3, 4, etc. up till n. 1, 2, 3, 4, etc. up till n. It has some n elements. Okay. For 1 to n. That means what? You have to check element 1 by 1 up till you reach the nth element. Okay. At each point, what you're supposed to do, you have to do an operation called select. At some point, you have to select one item. Okay. You're calling this as X. Whatever item you have selected, you're calling that as X. Okay, you're checking, is this a feasible solution? Now, when I say feasible, you should recollect. When will this be true? When the constraint satisfies, yes, it is a feasible solution. No means you drop that. You drop whatever you have chosen. If your constraint satisfied, if it is a feasible solution, this one, right? If it is a feasible solution, then what do? Whatever was there, union of solution, right? So if it is feasible, I will add to the solution. Add solution. Okay. Union of solution and x, or you can say you can add solution to x also. You can understand it that way. That means this was initially my solution is empty. I add whatever I had chosen. This first item, it's satisfied. Okay. Similarly, this is a thing, right? This is a loop. It will keep doing. That means what? Next, I choose my second element. Same thing I have to do. This becomes my x. Is x a feasible solution? Now, suppose say x is not feasible. Okay. Then you drop it. You don't add to the solution. Then you check your next element. Right. So that becomes your x. You are checking, is x a feasible? Say, suppose, yeah, x was feasible. You go ahead and add to the solution. Okay. So one problem statement, we will see how we can solve using greedy method. This problem statement is also called as knapsack problem. Knapsack problem. Knapsack means it's a backpack. Yes. Given that you have n objects and a knapsack. Okay. So what are you given with? Given means what? You have some input. Okay. So you have an input. There are two inputs here. This a bag is your input one, and you have some n objects, which is your second input. Okay. So when I say n, you can understand it like this: 1, 2, 3, 4, etc. up till n. Each object has a weight W. That means what? Every object that you pick up will have a weight. Again, relate to your shopping cart. Any object that you take will have some weight, right? You take a wheat bag, it will be say 5 kg weight. If you take a chips packet, that also will be having some weight, few grams, right? 50 grams, 100 grams weight. So any object has an attribute or a property called weight. Okay. And the maximum weight or the capacity of the knapsack is M. This is the constraint of the problem, right? Saying something else also. Each object is associated with the profit P. That means every object also has a property called P. This you can take it like money. Like when you say a wheat bag, it will cost something. When you say a chips packet, it will cost something. So every object that you pick will have some profit. Okay, profit P. That is earned. Okay, the profit is earned when it is placed in the knapsack. So when you define a knapsack problem, you can pick a whole or you can pick a fraction. Okay. Objective is we must fill the knapsack. So wherever knapsack comes, imagine the bag. Okay. We must fill the knapsack with which maximizes the profit earned. Okay. This is your objective. You should get maximum profit. And the output is a vector. Okay. So to prove your output, you should have a vector. Vector means this kind of a grid. Okay. Now, items in the vector. How many items will be there in the vector, in the output? Can your output have more than n objects?
No, ma'am.
No, right? Okay, that is very clear. N is your max that you can have. What is the min that you can have? Minimum, how many you can have? At least one you will have, no?
Yes,
Right?
ma'am.
So you can have your output between 1 to n. Because why we say between 1 to n, you could have just one object which satisfies the constraint. You remember, I asked you this question, how many objects will be there in the output? You said only those many objects will be there whichever satisfies the constraint, right? So you could have only one which satisfies the constraint, or say two objects satisfying the constraint, anything, but you say in good case, right? All your n objects satisfy the constraint. So your vector table can be as small as just one, or it could be as big as n. So that is what they're saying. What this says. Okay. This is saying you are going to maximize. You remember union? In the previous example, we saw union, right? So union or this example, this is called sigma, okay? Wherever you see this, this is nothing but add all elements, says. So our objective is to maximize the profit. So how do you get the profit? I need to pick xi. Xi is any element in this vector. Okay, so when I pick one thing, this is called xi. When I pick this, this is xi. So I need to make sure that whatever element I pick, that one's profit. So profit into the element that I pick, I and I, right? That should be maximum for me. Okay, but while finding this out maximum, I also always, you have to say constraint. Subject to means constraint. What is the constraint? The weight of the element. The weight of any element that I pick, weight of xi should be less than m. Okay, so our objective is to maximize the profit, keeping the constraint in mind. That is what you can summarize this as. Okay. We allow in a general knapsack problem, are fractions allowed? Allowed,
Yes,
right?
ma'am.
Yeah, there could be a special case where fraction is not allowed. Okay, that is nothing but 0-1 knapsack problem. I'll just mention it here. Okay, knapsack. Okay, if fractions are not allowed, okay, this is called 0 or 1 knapsack. Okay. 0 or 1 means what? Either the element is not selected or the element is selected. You cannot break and make like quarter of the element, half of the element. You cannot take fractions. So that is why it is called 0 or 1. That means the element is either not selected or selected. Okay, why I highlighted this point was, if they ask in the question, explain knapsack problem, you can tell, yeah, whole or a fraction. If sometimes they will tell explain 0-1 knapsack problem. So if it is 0-1, here you need to change. You should say that fractions are not allowed in a 0-1 knapsack problem.